Welcome. Karibu sana. How are you? We continue with our lessons as students are in the holiday. The exam is still around the corner, and within no time, especially the cadets, they'll be sitting for their end of 4 years exam, and for their sake and for the sake of those others who are in the lower grades, we need to do something and not just sleep in this holiday and going forward. So in our lesson, I have given it this headline: using the knowledge of the mole, that topic that we call the mole, to calculate relative atomic mass. So before we move on, I want to really appreciate you who has joined us. Welcome. The returning subscribers, feel welcome. This is home where we sharpen one another, and even as we are building on academic part of our students' lives. So let me begin by reading the question. 25.0 centimeters cubed of an alkali, and this alkali has been given the formula of capital M OH, where capital M is just a letter to represent a certain element that you can see down here. That is the letter that you'll try to know whatever it is there to represent. So 25.0 centimeters cubed of an alkali MOH completely reacted with 20.0 centimeters cubed of nitric 5 acid. The acid concentration was 6.3 grams per dm cubed. Per dm cubed also means per liter, as 1 dm cubed is also the same as 1 liter. And that of the alkali was 3.2 gram per dm cubed. Full stop. Calculate the molar mass of the alkali. The molar mass in this case is the R.F.M of the alkali, and hence the relative atomic mass of M. So that is the question. Copy it. So this is where we begin. As usual, in our previous lessons, I told you before you jump into the calculation, there is always that part of kujipanga. Unapanga swali lako so that as you move on, it becomes very easy for you to get the correct answer. So this is where we begin. First of all, we will write a well balanced chemical equation. So that is where it all begins. Without a well-balanced chemical equation, you go nowhere. So let's go back to the equation. Hata kama kuna element moja hatujui ni nini, we can still do the equation. So the reaction is between an alkali, and the alkali is capital M OH. If it is an alkali means a soluble base. So if it is soluble, remember we talked of anything that is soluble is in the aqueous state. So that is the MOH, completely reacted with 20 centimeters cubed of nitric 5. So plus nitric acid, an acid again is in the aqueous state. What will be the products? When you see an OH here, it means that this is a base, and this is already an acid. Even the name can tell it is nitric 5 acid. When a base and an acid reacts, we always get a salt plus water. Those are the products whenever a base and an acid reacts. So the salt in this case will be M nitrate. We do not yet know what M is, but at least there are a number of things that we know already, even without telling what M is. First, this MOH is an alkali. This MOH is an alkali. If you use the knowledge of the topic of chemical families in Form 2, alkalis are group 1 metals. So if it is if this one is said to be an alkali, then it means that M is a group 1 element. And if it is a group 1 element, that is why its valency is seen to be 1. How do we know that it is 1? Look at this formula. Even though hatujui M ni nini, at least we can see OH somewhere. Na OH as an ion, it is written as capital O, capital H, and a negative here. So meaning the valency of OH is 1. And if OH has 1, let me write it here, or go to the other side. So OH has this formula. It is a radical with a negative charge whose valency is 1, and that is to mean that MOH, this one, which has been said to be an alkali, with this name alkali, we are able to know two things. One, MOH is an alkali, meaning it is a soluble base. The same alkali comes from that topic chemical families in Form 2, whereby alkalis are elements, or alkali metals rather, where alkali metals are elements of group 1. So meaning M is a group 1 element. So that is a conclusion. So M, capital M, in the MOH has the valence 1. It is a group 1 element. So with that knowledge, then we are able to know when you are writing this equation, MOH plus nitric 5 acid, we're able to get the salt, which is M nitrate, and again nitrate ion also has a valency of 1. So if M has valence 1 and NO3 has valence 1 as well, then the formula of the salt is MnO3. And remember about the solubility of salts, all nitrates are soluble, so aqueous, then plus water, which is liquid. So after tumeandika equation, we check to see whether it is balanced. So let us go together. M is 1 on the reactant side. In the product side, M is also 1. We go to O, oxygen. We have 1 oxygen here, and these are 4 oxygen. A total of 4 on the reactant side. On the product side, we also have 3 plus 1, they are also 4. Then we go to hydrogen. We have 1 hydrogen here and another one here, so there are 2. And on the product side, we also have 2. So we go on to nitrogen. Nitrogen is 1 on the reactant side, and it is also 1 on the product side. So the equation is well balanced. From there, we go ahead and interpret the question. Remember, I told you before you rush to the calculation, you need to first of all make sure that everything is well interpreted. So how is the question? We are told 25 centimeters cubed of an alkali. So this 25, this one will be written under the alkali MOH. So down here we say 25 centimeters cubed of the alkali. We go on with the question. Completely reacted with the 20 centimeters cubed of nitric 5. So nitric 5 has 20. We write 20 centimeters cubed. I hope we are together. We are continuing with the question. The acid concentration was acid concentration. Which is the acid? Nitric 5 acid. This is the acid. We are told that the acid concentration was 6.3. So we come here and write 6.3 gram per dm cubed. 6.3 gram per liter. Remember, I told you that 1 dm cubed is the same as 1 liter. So tunaendelea na swali, and that of the alkali is 3.2. So alkali is this one, 3.2 gram per dm, or 3.2 gram per liter. What else has been given? So that 3.2 gram per dm, calculate the molar mass of the alkali, hence the relative atomic mass of M. So everything has been put where it belongs. So you see this arrangement here. ati unaweka kila kitu mahali inafaa. That takes you to the calculation, and once you have done this one, you can be very sure that you will get the calculations correct. So let us start. So let us start together. So from there, we look at both of them, MOH and nitric acid. We cannot use anything of the MOH because M is not known. Actually, that is where the question is. We are supposed to get the atomic mass of the relative atomic mass of M. So we can only start from the known. And the known is nitric 5 acid. For nitric 5 acid, we have two things. We have the volume 20 centimeters cubed, and also we have the gram per liter or per gram per dm cubed. It is the same as 1 dm cubed is the same as 1 liter. So from that, what has been given for nitric 5, there is only one thing that you're able to calculate first, which is molarity. Molarity of who? Molarity of nitric 5 acid. So molarity is usually calculated as gram per liter over the R.F.M. Are we able to calculate R.F.M of nitric 5? Yes, we can. How? By adding the RIM of these elements. The RIM of hydrogen is 1, the RIM of nitrogen is 14, and the RIM of oxygen is 16, and there are 3 of them. So this goes to 15 plus 48. This is 63. That is 63. So then molarity is equals to 6.3, which is a gram per liter, or over 63, which is the R.F.M, and this is 0.1 molarity. So having got molarity as 0.1, then from there we can use this molarity. You see, we have already used the gram per liter. You have already used the gram per liter. We are remaining to use the volume. So we use this molarity that we have got and the volume that we had been given. So we say 0.1 mole. This one now, the interpretation of capital M for molarity is that we have this number of moles in a liter. So 0.1 mole are in 1 liter, which is 1,000 centimeters cubed. 1,000, not 100, 1,000 centimeters cubed. Then we can always ask ourselves how many moles are there for in this volume, which is 20. You see, we had written that nitric acid has 20. So how many moles are in 20 centimeters cubed? Cross multiply the 0.1 times 20 is equals to 0.002 mole of who? Of nitric 5 acid. From there we get ratio by mole of nitric 5 acid is to MOH. The ratio by mole is 1:1. If you look at the equation, the ratio by mole is 1:1. So from there we say if ratio 1 of nitric acid has 0.002 mole, what about ratio 1 of M hydroxide? So you cross multiply, so 1 times 0.002 over 1, so you get 0.002 mole of M hydroxide. Mole of M hydroxide. I hope you're still together up to there. From there I want to use this little space there to avoid rubbing some of the information before we are through. So this 0.02 mole of MOH are in this volume 25. So how many moles are there for in 1,000, so that we can get the molarity? So it is 0.002 times 1,000 all over 25. So we get 0.08 capital M. The question that we have is asking us, let us reread the question once more. Calculate the molar mass of the alkali and hence the relative atomic mass of M. So molar mass in this case is R.F.M. And the formula that we use to get R.F.M is gram per liter over molarity. And the gram per liter that you have been given is 3.2 all over 0.08, which is the molarity. So we get 40. So for you to get RAM of M, capital M, we get 40 minus, remember the formula of MOH, we have to add the relative atomic masses. So we have the M that we are calculating, we have for oxygen. So for oxygen we have 16, and then we have for hydrogen it's 1, so plus 1 is in conclusion we get 40 minus 17, so is equals to 40 minus 17 is equals to 23. So that is the final answer. RAM of capital M is 23. And just like we had predicted, that now that we have been told that this is an alkali, and an alkali on one side is a group 1 metal, meaning capital M is a group 1 metal, and those hydroxides that are prepared using group 1 metals, they are called alkalis. They are soluble bases. So having got 23, this 23 is the R.I.M of sodium, and sodium is an alkali metal, and whenever we have a hydroxide of sodium, it is usually soluble in water, so it is an alkali. It is a soluble base. Remember, bases are the oxides and the hydroxides of metals, and if it is a hydroxide or an oxide of group 1, then it is an alkali, which is a soluble base. So I want to leave it at that and say that just in case you didn't get the question, I will briefly read it to you. 25.0 centimeters cubed of an alkali MOH completely reacted with the 20 centimeters cubed of nitric 5 acid. The acid concentration was 6.3 gram per dm cubed or per liter, and that of the alkali was 32 gram per liter or per dm cubed. Calculate the molar mass. The molar mass is the R.F.M, the relative formula mass of the alkali, and hence the relative atomic mass of M. So that is all we have done. We started with the equation, it was balanced. We went to nitric acid because it is the one that we knew all about. We could not use the MOH because M is unknown. Then those are the many steps that we followed. Ratio by mole. We got the mole of MOH. We came here and got the molarity, used the formula R.F.M is equals to gram per liter of molarity. We got the molarity 0.08, the gram per liter is 3.2, so the R.F.M is 40. For you to get R.I.M, you need to get the R.F.M, which is 40 minus the R.I.M of oxygen and the R.I.M of hydrogen, because remember it is we are having MOH. So for you to get the R.I.M of M, you need 2, and the total we have seen as 40. So you take the R.I.M of oxygen, the R.I.M of hydrogen plus the R.I.M of M equated to 40. So that's why we are coming to this. So R.I.M of M is 40 minus that one of oxygen plus that one of hydrogen. So it is 40 minus 17, which is 23. And actually, that was the correct answer. So that is all.